So probably we should start. My name is Valery Kravchuk. I obviously work for Percona. I'm working in support. And maybe just a couple of details about myself. Of all these, the only important things are for 10 years or so, I'm working mostly on bugs-related MySQL problems in different roles. That's why I was exposed to, debugging and debugging tricks for quite a long time. And this also explains why I'm speaking and thinking and talking about MySQL mostly in terms of bugs. So whatever presentation I make, whatever topic I try to cover, it will surely include some links to real bug reports, community bug reports, and whatever. I'm just thinking about MySQL that way in many cases. So that's all you should know. I'm writing here and there, more or less, based on these ideas, that MySQL is surely about bugs, and you should be aware about these bugs. And you can study a lot and understand a lot about based on reviewing bugs. So this session is called basically how Gdb GNU debugger can be used by MySQL DBAs. It's a bit maybe strange idea from the very beginning because debuggers are used by developers. Debuggers are used maybe sometimes by quality assurance people, by people who would like to understand how things work and maybe to break it. It's a hacker stuff, and maybe second or third already a kind of hacker presentation, that's why. But you should not be scared of debugging things, and you should even try to do that for one good reason. You are working with an open source software. So to debug software properly and to use debugger in a reasonable way, you need two things. You need access to source code. Without that, you are more or less on your own because you can see low-level details in debugger, but you do not know the high-level ideas. You cannot see the code and you cannot understand what was the idea and what really happens. And surely you need to use your brain, but that's already was said by Lefred. So I wanted to start with some details on who actually got the idea that in production, normal MySQL DBA may ever need or have to or may benefit from using GNU debugger or whatever debugging tools are available for platform. So I've collected some links, and you should note that this presentation is already available at the FOSDEM MySQL friends site, so you can just download it, and everything that you see underlined, it's a live link that you can click on and get into the details. So it's a short reference, reference material for your further use. So after I explain a bit of history, the way I understand it, it's my personal understanding, some of you may know more details or different interpretation of how we ended up with using Gdb, even in production. So then I will remind you about the way how MySQL actually works. It's a multi-threaded process, and it's important. So if you want to apply debugger, you need to know how to debug multi-threaded programs. Then I'll just share a couple of comments. Maybe I will just show them alive as well, because I have Percona server already running in the virtual machine here. And, well, we can always just, switch and, yes, it's readable, great. And see what happens if we have some extra time. So one of the most important and well-known uses of debugger, actually, that made its way even to Percona toolkit eventually, is PT.PMP, poor man's profiler. And PT.PMP is just a useful and very important tool that was based initially on single Gdb command, and an idea that it can be applied to a server. So we will check a quick reference, of mostly complete reference of what poor man profiler is and how it works, as well as when you should really try to attach it to your live production MySQL server. When it's actually the only other thing you can do is just to restart it or kill it. So it's just about correct time to do that. I've explained that you need to know the source code. Nobody can expect from even the best DBAs to know all the code base of MySQL, and it's not needed in most cases. But you need to know some basic things. You need to be able to search the code, understand the structure, and you need to know some data structures. Of them, surely you need to know global variables, and you need to know some parameters of some function calls, important one. And one of them is thread handle. So almost everything in MySQL, as it's multi-threaded, it's based on specific thread. And you need to know thread structure. That's starting point for all your further study that you can make. So I will share also some real-life cases, links, and then if we have time, we can try to play or maybe even discuss. So for me, historically, the use of GDB in production started with the guy whom you should know well. His name is Domas Mituzas. He is a well-known MySQL hacker, and at the moment he worked at MySQL support with me. So he did all kinds of tricks with all kinds of software available, with the dtrace when he had dtrace, with everything. But one day he just published a blog post and then created a site and then started to use a very simple tool called Poor Man's Profiler that actually did one simple thing. It printed a backtrace of all the threads, did it many times, aggregated results, and presented them. So it was a GDB call with some details on top. Based on that great success, and maybe in parallel, he also published a lot of smaller things. Next step would be, first step is to read the data with GDB, and next natural step for a production DBA is when you understand the data, you can try to outcome some MySQL or MySQL configuration problems for your specific running instance by trying to change things in the running image of MySQL D process. So he was writing all this. You can check these historical references, check them carefully, because many of them, or even most of them, other than Poor Man's Profiler, it's forever, they are outdated, and your real need for GDB depends to a large extent on the version that you use. If you work on different versions of MySQL, and if you are careful comparing and reading the manual, you probably noted that with time, there were fewer and fewer things that cannot be changed in MySQL at runtime. At 5.7, we will be able even to reconfigure and resize in a DB buffer pool, for example. But in the older versions, many settings were read-only and required restart. So this is where you should immediately think and check the tricks. So, and many tricks are outdated because people, for example, tried to change max connections setting. It's not even needed anymore, it's dynamic. Some of the settings are still read-only, and that's why tricks might still apply. Also, please pay attention to this last link. When bad things happen, I should tell you from the very beginning, when you attach the GDB to a live MySQL D process, and then you detach from that process, bad thing may happen, like the process may remain in the state when it's not running. For example, it's traced at the moment. You may get a crash. If you are lucky, only GDB will crash, for example. If you are less lucky, you may crash your MySQL D process as well. Last link explains what is going to happen or what you can do if your MySQL D still hangs. The idea is simple. You should send a signal seek continue, but you may need to do that more than once. And Thomas presented some experience. So as I told you, for me, the history is actually started with Domus, but it doesn't mean that he's the only one. Other well-known community members later stepped in. And if you're interested in studying what people do with GDB, I suggest you to remember these names. Another name is Shane Bester, single-person Oracle MySQL QA team, and the most well-known contributor to the public bugs database. You should remember Royal van de Par. I give you links. So it's a lead of QA here at Percona, who also continues to work on the approach of using GDB on top of core dumps. Not, that's less interesting for production DBAs, but here it works a lot of getting as much data as possible from every single crash that they ever can get at QA. That approach still might be useful for you as well, because when you report a bug or when you open support issue, you might be required or asked, can you reproduce it? Do you know what SQL crashed? And if you do not help immediately, then you may be required, for example, to provide the core dump if you cannot work on it yourself. And core dump may be really huge, and at least it will postpone some further actions, while with crashing statement, for example, you can get immediate workaround, like some hint or some settings magically changed and stop crashing. That works. Surely other Facebook people, my colleague Aurimas, who's here, is also famous for trying to apply GDB. Recently, there is a great Chinese guy, Wei-Xang Jai, who use PTP-MP a lot and report a lot of bugs. So just check. They are public, they are writing. So basically, what you can do with GDB, you can get a backtrace sequence of calls in each of MySQL threads, either from the core dump or from a live process that you attach to. This is easy. To interpret it, you need to understand the code and some data structures. You can jump from one thread to the other. There are many threads running. If we skip things like multi-thread pools, then we should assume that each connection to MySQL is a separate thread. And beside that, there are many background threads, often dozens of them. So you can switch to any of these threads and print local variables, check local variables, print whatever. In some cases, you can go as far as to print structured variables. So if you know GDB well, you may point out specific item of specific structure in specific frame even without referencing, like that command shows. If you are just looking, you can print everything. You should use commands like info locals, for example, or info variables, and see what's there. Be ready to get screens and screens of output. But that's also the way to start. Surely you can use set command, and you can change whatever local or global variable at this moment. Program is stopped, execution is stopped, and with the next instruction, you will see different values. So you can try to fix some things. Theoretically, you can capture, I don't know, running query and change it on the fly, probably. But in most cases, we speak about setting new values for read-only variables that defines the behavior. Or this way also, you can work in cases when you already hit max connections. You cannot connect as DBA to your server to change something that is already dynamic. That's great, but you do not have, for example, single additional thread that is for root is already used by some process, maybe some your monitoring stuff, and you still need to connect. You can do that with GDB. And that's why you need set variables. You can call functions, all other things I've just mentioned, because breakpoint, watch points, and all that stuff is mostly really used by developers when they study your results. But you should also remember that you may use GDB as a command line tool as well. So it's not only interactive, it's a command line tool. Quick reference to what ended up as Percona poor man profiler based on original ideas from Domas. What's good about the tool that it knows that it's for MySQL, so actually it connects, attaches to MySQL D process automatically. If it's a single process, you can simplify the command. And then you can control how many details you can get. Check the bugs there as a useful links of how people can understand what's going on with their servers by attaching Gdb to hanging MySQL D process. So there are 3 examples. They're all interesting and they're all different. And these are real bugs that were found and easily understood because of PTPMP. For example, hanging on shutdown. Okay, you can kill it, but you would like to understand why. That's it. So, as I told you, we should understand that MySQL D is a multi-threaded program. So we have a set of threads. In each thread, we have a sequence of function calls, frames. If you would like to understand what values had specific variables had at specific call, you need to go to a specific frame. And then you can print, for example, any local variable or any parameter of the function, whatever, in this specific frame, because from call to call they may be changed. So the unique reference is thread, frame, and then specific variable. Of the important structures besides global variables that you should also study, either from the code or from strings dumped from the crash, you should understand one single structure. The better you know it, the better your general understanding of MySQL. It's a thread structure. First thing to do, where to find it. Sometimes it's not obvious. You can use grep, but I will just tell you that it's defined in SQL class H file. Second thing you need to know, it's a class. And it inherits properties from other classes. So sometimes looking at thread only is not enough to find what are the details. You can actually print thread in Gdb and get many screens of output, structured output to get the idea what's inside. But I'll give you some hints. You know, it inherits from statement, and it inherits some things from table handles. But some variables are quite obvious. You have user variables, you have global variables, you have status variables. The same you get with show variables, show status for the thread. You have security context. And you eventually have query string, but it's inherited from statement. So you cannot find it in thread itself. How it works? It's a real-life use case that I would like to explain. Recently, we got a crash, and we knew the crash in query from customer. But this query was executed by the application with many users connected. So they need to know specifically where this code path was hit, on what specific host and by what specific user it was executed. So by dumping all strings or using fullback trace, we have many threads. Surely we can identify the specific thread. And if we print everything for the thread, eventually we will find out. But just a quick hint that helped in reality that if you know where to look, there is a security context, you can find out. When you know what they are looking for, if you suspect that it's, for example, a root user, you can easily understand it on screen. But if you are debugging a complex process, then you have to rely on knowing the structure. This helped immediately to work around the problem. They just had not allowed this user to connect anymore. That would also happen in case of real crashes. So to complete, actually, I think I do not have that much time left. To complete that presentation, so one thing is to attach to a live MySQL D process. Another thing is to use core dumps. If your server crashes, to debug this problem either yourself or work with any support provider or to report a public bug, you really need to understand what's going on. And for that, as you were not able to attach debugger in time, so you need a core dump. For core dump, you need to know two things. First, make sure that it's created. It requires some steps depending on the way you run MySQL. Do you run it as root or not? What kind of Linux you use? how much security hardened is it? So this is a separate topic. Where core dump is created. So as soon as you have a core dump, you can just, you will be required to get a backtrace either with all the variables or not. The results will be easier to interpret or harder to interpret depending on what build of MySQL you use. Does it have symbol table or it's stripped or not? But it's like not your problem. And if you plan to work on that, I would ask you to train yourself based on test instance first. Make sure that core dump is created. And if you are curious how to crash MySQL, maybe you don't know. Here is a link, a crash and bug that crashes both Percona server, optimized binaries, and upstream MySQL. Test case is there. So it's public. That's it. And finally, a small case of changing variables dynamically. You can pick up manual page for your version, find any not dynamic variable, make sure you cannot change it via SQL, then you can use Gdb in batch mode. Again, make sure you tried it at least once, batch with one dash, how to identify process ID of MySQL D process, what to do if you run in several MySQL D process per operating system, it happens. So things may get complicated. But eventually, after you change this read-only variable, you can reconnect and check that it works. Surely, when you detach the debugger, you may leave the process in the thread as traced. You will see it in the PS output. And simple solution that may work, may be enough just to send one signal. It may not work, depending on how you code it. You may have to thread it again and again until you send it to a proper thread, a proper group leader that was actually traced. So be ready for that. That's all from my side. Again, it's more like I tried to give you the idea of where to look at if you are curious and if you are planning to apply these techniques. It should be applied as a last resort. It should break things. But if you are already going to restart your MySQL D server, you have this tool and this approach to do. And the last word, surely report bugs, please, at bugsmysql.com. This is what I care about. So, it just works. Yes. Yes. It makes a lot of sense right now. So I am just, quit. Yes. Let's check if I have alive MySQL D. Yes, I do. And then we can just do it here, ptpmp. By default, I will do nothing. Well, now I will not see anything interesting, really, because I do not put any load. Well, you see that's an aggregated trace. I have single thread, but still at the top, it's a typical top command that you should just skip. It's background threads of InnoDB that are doing asynchronous IO calls all the time. But here, sig-wait, select, we are waiting for further connections and we are doing things. As soon as we have some SQL, my favorite SQL is benchmark function. Benchmark. I don't know, 2 plus 2, things like that. Right. So while it benchmark, it's a universal way to understand. Well, probably I've mixed the arguments because it cannot be too fast. Yes, right, so now it works. When benchmark is fast, MySQL will be fast on this machine. If it's slow enough, single thread performance matter. Then whatever you do, it will be slow. It will not scale. So it's like a basic fact. What you can see at the last row, you can see that benchmark function is called. This is, again, obvious. If you have multiple threads, we can aggregate it that way. What's interesting that it just works by default. PTPMP was created and modified by Baron Schwartz based on original script, some AVK and shell foo applied on top. And that's why it's easier to apply than original script from DOMOS. But it's still also widely applied. Some people may be scared of the word percona in PTPMP. Yep, thank you very much. Sorry. If you have any questions, just feel free to catch me and ask.